Hi everyone, I am Ruzbeshad and welcome to my YouTube channel. This video is the first in a series of videos in which I'll explain how to create a software application based on the Northwind database. In these videos, I intend to share with you many of the techniques and experiences I've learned over the years. In this part, I'll teach you the reverse engineering method using Entity Framework Core code first with existing databases. In each of the next videos, I'll complete a part of the software application along with you. I'm sure this collection will be very attractive and exciting to you, and you'll enjoy it a lot. So join me on this journey and enjoy every moment of it. One more time, I'd like to remind you of subscribing to this channel if you haven't already, so that you get notified of the future videos and never miss them. Are you ready? Let's get started. Alright, let's start by opening Visual Studio and creating a .NET Core class library project. The reason we've selected this type of project is that it will contain classes and other definitions that are referenced by the other parts of our software application. This class library is going to serve as the data access layer or data tier that is a component of the application, which is responsible for communicating with the database to get and store data. Some developers append a DAL suffix, which is the short form for the data access layer, to the end of project name. Others use DAT, which is short for data, as the suffix, but I personally prefer to use data with a period at the end of name for this type of project. So let's call our project northwind.data. Set the solution name to Northwind. Enter a path for the solution and project. Leave this checkbox unchecked. Finally, click on the Create button to create both solution and project and close the dialog box. Note that we've used .NET Core, which is the successor to .NET Framework and highly recommended for new projects. Unlike .NET Framework, which is most suited for Windows applications, .NET Core is a cross-platform framework. That means libraries and applications created with this framework can be run on multiple platforms, that is Windows, Mac OS, and Linux. Before proceeding with your work, delete class 1. You'll use a feature called Entity Framework Core code first with existing databases to reverse engineer the database. So you'll need to install the latest version of Microsoft ORM, that is Entity Framework Core. What I mean by the latest version here is that the latest version of the package that matches the version of Target Framework used in the project. You can check the version of Target Framework used in the project either on the Project Properties page or from the project file opened in the editor window. Alright, now right-click on the solution and select Manage NuGet Packages for solution. On the NuGet tab, click on the Browse link and enter Entity Framework Core. From the list of packages that appear, pick Microsoft.entityframeworkcore.sql server, then select your target project in the middle of the screen, that is Northwind.data. From the version drop-down list, select the latest version number that matches your project target framework And finally, click on the Install button to add the package to the project. If it shows the Preview Changes dialog box, click on OK to close it. It also shows the License Acceptance dialog box. Accept the license terms for the package and close the dialog box. That's enough to connect and communicate with a database on SQL Server. We also need to add a tooling package named Microsoft.EntityFrameworkCore.Tools to be able to issue migration commands like add migration at Package Manager console prompt. So let's add this package to the project too. Okay, now we can do a scaffolding the database, but before that, I'd like to draw your attention to something important. If you have a look at the database tables, once again, you'll notice that the table names are plural. So scaffolding the database will generate model classes with plural names, that is categories, products, and so on as class names. We should use singular names for the domain classes. There are different ways to achieve this goal. Perhaps the easiest one is using another NuGet package called bryslam.entityframeworkcore.pluralizer. So let's add it to the project. It's worth noting that the default behavior in EF Core version 5 is to generate singular names for entities, and there's no need to add the recent package if you use that version of EF Core. Now it's time to reverse engineer the database. To this end, open the Package Manager console by clicking on the Tools menu and selecting Package Manager console from NuGet Package Manager submenu. At the command prompt, type the following command. Note that we've used data annotation switch to decorate classes and their properties with attributes. This way we decide to configure our domain classes using both EF Core data annotations and Fluent API. I mean, we are going to do some configuration using data annotations and the remaining configuration using Fluent API, which I believe is a better and easier method to maintain our model. Not all of the tables and views are used in this tutorial. That's why I have used tables parameter with a list of tables that we are going to import as domain entities in our model. If you want to use views in the future, for example, there's an easy way to do that. Now press the Enter key to execute the command. Alright, scaffolding is done successfully, and as a result, you see a number of classes have been created and added to the project. When using EF Core code first with existing databases, always create an initial migration immediately after scaffolding and before making any changes to the model. So at the PMC prompt, type add migration, initial create, and press enter. You'll find that in the Solution Explorer, it has created a folder named Migrations and put a C# class in it with a migration name and the timestamp as the prefix. It has also opened the migration class in the editor window in the main area of Visual Studio. As you see, there are two methods in this class. In the up method, you find the statements which usually modify the database schema. In the down method, there are statements to undo those changes made to the database by the up method. The up method gets called when the migration is applied by executing the update database command. Remove code from up and down methods because this will not work as we already have all objects in the database. Next, run the update database command in order to update the existing database with the initial migration. Now let's have a look at one of the classes, for example, category class. Each instance of a class in the model, like category, represents a row or record in the corresponding table in the database. Each property in the class maps to the corresponding column in the table. The key attribute of the category ID property identifies it as the key for each instance of the class and maps the property to the primary key column of the table. The column attribute is usually used for mapping between property and its corresponding column in the table when the names are different. It's also used for mapping C# data types like a string to SQL data types like Unicode text. The required attribute for the category name property denotes that it's a required field and usually used for validation. String length specifies that the maximum length of the category name is 15 characters and used for validation too. The products property is called a navigation property. Navigation properties hold other entities that are related to this entity. In this case, the products property of a category entity holds a list of products that are related or belong to that category. In the next videos, we'll be back to these domain classes and make some improvements to them by using class inheritance and features of the EF core. Okay, it's time to have a look at the context class. If you open the class in the editor, you'll see that scaffolding has created two constructors. The parameterless constructor that just creates a new instance of the class without configuring it, and another constructor that takes a parameter of type of dbContextOptions class. A parameter of this type carries configuration information such as the database provider to use, any necessary connection string or identifier of the database instance, and so on, and provides this information to the context class so that it can connect to the database and communicate with it. You'll see later that an instance of the context class with such information will be created by the Web API using dependency injection. After the constructors in the Northwind context class, you see a number of definitions for entity sets using the dbSet properties. Each entity set corresponds to a database table. Since an entity set contains multiple entities, the dbSet properties should be plural names. After dbSet properties, there's a method named onConfiguring. This method gets called when every instance of the class is created. An instance of the class might be created without passing dbContextOptions parameter. In this case, we say it's not configured because it has no information how to connect to the database. This is exactly true when using migration commands included in the Entity Framework Core tooling. Such commands create an instance of our Northwind context class and need it to be configured by calling the onConfiguring method. In such situations, onConfiguring method gives us the chance to check if it's configured properly. Otherwise, we can provide it with the correct information like connection string. Finally, you'll see a method named onModelCreating. This method contains Fluent API and used for anything that cannot be configured using data annotations. That's all for now. If you enjoyed this video, please give it a thumbs up and subscribe to this channel for upcoming videos. Thanks for watching.